Welcome to SirMajesty.Sure A1. Today we'll be having the real analysis of an organic compound. This sample here, an organic compound that is glucose, but we want to see how we can really confirm that this is glucose or some chemical property that concerns glucose. Remember, this channel is concerned with analysis, so you can order for your quality control measures with SirMajesty.Sure A1, and then if you're finding any compound difficult to analyze, you can forward to us. Let's see what we can do together. Please, if you have not subscribed to this channel, endeavor to do so. Subscribe and share this video. So, first of all, the glucose is highly soluble in water. Your first step is to add in a given volume of water. This is the examiner, or any time you analyze it, this might be core sample. Any letter can be used, maybe sample C. So in this case, we are dissolving. It is highly soluble in water, of course. So we get enough solution of it, from where we now make other tests. Okay, there will also be the inorganic compound, the zinc oxide analysis. Okay. Normally, you need to use a glass rod to facilitate the dissolution. Okay. It's highly soluble. It's dissolving. Yeah, of course, giving us a clear solution. These are the reagents we need for this analysis. So the first step I'll be taking here is you will be asked to collect a sample, and then, as you can see here, then add acidified potassium heptaoxodichromate 6 and keep. This is acidified potassium heptaoxodichromate 6. Is orange in color, and this is white. But on addition of this and keeping it, let's see what happens. Okay, by adding, okay, just add and keep. See, the color intensity are no more exactly the same. I see this one over here is turning green gradually, so you keep for some time. And let's proceed to the next thing. So the next thing is to collect a sample, a second sample. You see the camera is there. With time, this will start turning gradually green, of course. So I added enough. If you compare the two, they are no more the same in intensity of their color. So another sample is, if you have, you'll be told to collect another sample like this. That's where we might use the Felling solutions A and B, because I've given you the theoretical analysis of this compound, glucose. In this video, I'm now giving you the practical analysis of it. Over here is Felling solution B, and here is Felling solution A, which is copper 2 sulfate 6. Then Felling solution B is actually sodium tartrate filtered, so you'll be required to add the Felling solution A first, then add add A, then add B. So over here, the blue one is the B. Okay. The blue one is the A, sorry. So, and this one is the B. Add it. There is no visible reaction. We also add to about 1 cm cube or 2 cm cube. We add about 2 cm cube of each. Okay. So the next is to warm gently. We're going to take this to warm. But before we proceed to warming, let's do other things and show you what happens on warming. On warming this, it turns brick red or orange red, which confirms the presence of reducing sugar. We check our first analysis, you see it's gradually becoming green. You compare the two colors. So the next thing is to proceed to what is going to be likely silver mirror test, but the silver mirror test might be unlikely. Reason is just because it might take time to form, unlike this one now that has started turning green. So when you say the glucose unknown sample turns orange, acidified K2Cl2O7 green, you say reducing agent present. So this indicates that glucose is a reducing agent. If you want this change of color to be very fast, what you are going to do is to add more. You acidify your reagent more. That is it. If you acidify this more, but very careful about you yourself, because H2SO4 is corrosive. So if you acidify this more, the rate of color change will be very, very fast and more pronounced. But I think it's obvious in the video that the glucose has turned the orange color of K2Cl2O7 under acidic medium green, and that confirms that glucose is a reducing agent. Okay, the next one is where we're going to carry out something like a silver mirror test. This will take time to form, but we will do that. So first of all, we have to, maybe I will use a boiling tube. Okay. First, you might make the Tollings reagent. How you are going to make the Tollings reagent is to add the so-called silver nitrate to sodium hydroxide, or add sodium hydroxide to silver nitrate. So we need sodium hydroxide, silver nitrate, and aqueous ammonia. So over here is the aqueous sodium hydroxide. Then on adding silver nitrate, there will be a precipitate. See, there is a brown precipitate. Is a brown precipitate. Of course, is there. Then they are required to follow it up by adding ammonia until the precipitate becomes clear. See, the brown precipitate dissolves. So what we have here now is the complex ion silver 1 diamine, of which if you add more of the, introduce more of the silver, some of the unprecipitated oxide will form. Okay. So the brown precipitate is actually the silver oxide. Okay. The brown precipitate is a silver oxide. Okay. So our Tollings reagent is ready. So the next thing is to add the sample. This is the reducing agent, the glucose, which is an alkanal, into this, and keep. So you will start noticing, that's why I say this might, exam bodies might not ask this because it will take time for this reaction to occur, and then the time taken might not allow if it is in exam, but in real analysis, if you allow this on standing without adding more glucose, I've exhausted the glucose solution I have made, so maybe I'll make another one. So with time, you will see a coating of silver on the wall of the test tube. It might last up to 20 to 30 minutes. So I'll give you a sample of what this looks like after some minutes. See over here, this is the sample of what it will look like. There is nothing inside this. So see I've inverted this, so it means there will be covering or coating of the inside of this test tube with what? Silver metal, due to the reducing. You see, it is not becoming very clear again, it's becoming cloudy, and eventually there will be deposit of silver by the reducing sugar. So that's what we call silver mirror, because there will be a silver mirror coating the inside of the test tube. Okay, so this is the possible thing we need. Let's check the comparison of color intensity. You see, it has become clearly now that it is green on standing. So that's it. So the analysis of glucose is almost complete. This takes time, but it will form in a very smooth way. Like I told you, it might take 30 minutes sometimes, but this is what it will look like. These two layers, they are all silver coated, only that I added more glucose to this just to design this to make it more lovely. So if it stands now, after a while, if I add glucose again without shaking this, it will form two layers. So, but they are all silver mirror coated, and hence the name silver mirror test. Guess it's too clear there, the camera. Okay. Now, as we keep this aside, the zinc oxide is an amphoteric oxide, and if you want to know more about zinc oxide, you should know that it is going to be soluble in acid and also soluble in base, but will not liberate carbon dioxide in both cases. Some might tell you that if you add dilute acid to zinc oxide, it will be effervescent. No. If your own show effervescent, it means you bought the wrong zinc oxide. The problem here is that zinc oxide and zinc carbonate all turn yellow on heating, and on cooling they become white. So that's why if you use heat to distinguish zinc oxide from zinc carbonate, they will all behave the same way. They all turn yellow on heating and then white on cooling. Not that zinc carbonate turns yellow on heating, it's actually the zinc oxide that turns yellow. But when you heat zinc carbonate, the carbonate will decompose to yield zinc oxide, which is already hot, turning yellow. So it is still that same zinc oxide. But I'll show the difference between you, because some of you might go there and buy wrong zinc oxide. Buy the zinc carbonate. If you use heat test, it automatically turns yellow on heating, and then on cooling turns white. But how do you know zinc? How do you distinguish zinc oxide? If you watch this thing on standing, I think you see it's turning gradually. It's forming that brownish silver deposit on the walls of the test tube, which when left for a while, you see it's becoming more like this. So there is deposit of silver as I'm explaining this already. But I want you to know the difference between zinc oxide and zinc carbonate. I'll demonstrate it here. So zinc oxide will turn yellow on heating and white on cooling, but we show no effervescence when you add dilute acid to it. Zinc oxide will have no effervescence, but zinc carbonate will show effervescent on heating. So you see the effect of heat on zinc oxide. It is white, as you can see there on the screen, and then turns yellow on strong heating. So, but we have to know that some solids can be yellow when cold and when hot. That is probably lead-2 oxide, but some species, some lead-2 oxide are actually reddish brown or red on heating, but yellow on cooling. So if a solid remains pure yellow after cooling, and then on heating it turns reddish brown, it is lead-2 oxide. But zinc is yellow when hot, as you can see on the screen, and then cold, it becomes white. Okay, now I think this is possible because suppose you want to check the time interval. If this can form in 10 minutes, it means that the silver mirror experiment might be possible. But for you to get a clear result, you have to see, you have to take 30 minutes, and you see this test tube being covered with a nice and smooth looking silver metal. So what is covering here is actually metallic silver, which was reduced from the silver ion, that's silver 1, diamine silver 1 ion that was formed from the Tolling's reagent, the glucose solution, reduced heat from silver ion to silver metal, and that makes this test tube to shine like a silver coating. I have an exclusive video for this silver mirror test. You can watch it very well and understand other chemistry behind it. So right now I want to show you if you have a pure zinc oxide. So over here is expected to be the zinc oxide, which we have shown you what happens on heating and then on cooling. So I'm collecting a sample of it. Remember, zinc oxide is insoluble in water, unlike glucose that is soluble. So you might be required to test the solubility of zinc oxide in water, in acid, and in base. I'll show you those ones here now. So here is the zinc oxide, and over here is the, okay, let me get another sample of another powder. That's over here is not the pure zinc oxide. It should be the zinc carbonate. But if you heat both of them, there will be yellow on heating and then on cooling turns white. So over here is my HCl, dilute acid, dilute HCl. So I want to use this acid to distinguish between pure zinc oxide. So over here, you see, there is no visible reaction, but it will eventually dissolve. You see, to dissolve with time. But here, see, this one is purely zinc carbonate. By this one here is zinc oxide. So if you heat both, they will turn yellow. So if you are required to add HCl to zinc oxide or any dilute acid, don't report effervescent, because zinc oxide will not give you effervescent on heating. I mean on adding dilute acid, but will dissolve. So this zinc oxide, you see, has dissolved in acid. It will also dissolve in base. And then two of them will dissolve in acid also. Even the carbonate and the oxide will all dissolve in acid. If I add more of this, the effervescence will keep occurring until it becomes clear. See, the precipitate is no more. So both of them are soluble in acid. That's zinc carbonate and zinc oxide. But the difference is that there is no effervescence if you add dilute acid to zinc oxide. But if you add dilute acid to zinc carbonate, there will be effervescence, liberating carbon dioxide, which turns lime water milky. So these things is only for people that are experienced in analysis. So you're advised to buy from SirMajesty A1 to know the differences. So it's not just because sometimes the marketers, they use they leverage on your ignorance and then sell everything to you. And this channel is for analysis, not really for exam. They're helping teachers who really want to know the facts. So we have distinguished between the so-called zinc oxide and zinc carbonate. And now this is evidence that zinc oxide is soluble in acid. So I have to keep again. You see, our silver is forming gradually. You see, it is gradually turning, having a very shiny deposition of silver metal with time, and that is only alkanals can do that. So glucose is an aldose sugar, which means it has the functional group CHO. Okay, so having seen the solubility of zinc oxide in acid, let us check the solubility in base. Being amphoteric will dissolve both in acid and base. I will now add, this is the zinc, so I think you see these two, but the carbonate will not dissolve in a base. So most of you will buy the carbonate instead of the oxide. So, well, this is the reality. Then what if you buy the carbonate instead of the oxide? What must you do? Subscribe to SirMajesty A1 and then stay close for more details and more uploads. Okay. See, this is these and these are becoming similar in appearance. Now, these are the things you are required to know about this analysis. So thanks for watching and remain majestic. Please don't go without subscribing. share this video to spread the light. The learning of science should be done practical and not just theoretically. So I did it theoretically to guide you. Now you have seen the practical aspect. If you need any guide as a teacher in terms of analysis, you contact Her Majesty with the number you see there on the screen. Much love from me to you. Bye for now. I love you. Let's take a break and see this majestic periodic table. Then the clear answer to this analysis will follow immediately. The electronic configuration itself is all written starting from hydrogen down to the organesium, which one? That one bearing atomic number of 118. That's up to 118. Then coming to the classification of the elements, this is just purely majestic. It indicated many groups and classes of elements that you never know they exist, and explained most trends. So it is purely a summarized chemistry textbook in form of a table. You see that classification you see there, you see the alkali earth metal, the alkali metals, the halogens, the chalcogens, indicating the common names of each group. Apart from the one that is commonly known like the halogens, you have the all-formers, the chalcogens, the nitrogen family. This table has come to answer your questions as a chemistry teacher, especially if you are in the class teaching. Your job is just to point at that table, and the information you want will be there for you. Then, this table do not only just contain the configuration, it shows the order, the half-bar order, how the electrons fill the orbitals. Why do we write 1s first? Then after 1s, we go to 2s, 2p. You see the arrow down indicating. And then it shows the number of shells present and the maximum electron each electron shell can hold. Their common name, the K shell, the L, M, N, and also showed the formula for the maximum electron each shell can hold. So I cannot mention them all. Place order for your own copy of this majestic periodic table. You will not regret it. I've come to help you learn chemistry. I've come to help you teach your students very well. Present this. Can hang it everywhere. Remember, the periodic table, the Mendeleev table, is one of the most popular tables, and that's the table that represents science, even though it's chemistry. But anywhere you see that table hanging, automatically you know that this particular institution or this organization is scientific. Much love from me to you. Remain majestic. Bye for now.